Welcome to Session 9, Trigonometry.
An angle is made up of two rays. A ray has one end that is a point and the other end extends out for infinity. You form an angle by taking two rays and rotating one ray away from the other ray. The other ray, the one that does not rotate, is called the initial side and it is fixed. The ray that rotates away is called the terminal side. An angle is said to be in standard condition when the intersection of the two rays is placed on the origin in an xy coordinate plane, and the initial side rests on the x-axis. If the intersection of two rays is placed at the center of a circle, it's said to be a central angle. Now, because the two sides of the two rays extend out forever, it's going to intersect the circle in two places. This will divide the circle into two pieces, one piece inside the angle and one piece outside the angle. The piece inside the angle is called the intercepted arc. Two angles are said to be coterminal if they have the same initial side and their terminal sides are in the same spot. Coterminal angles are always separated in their measurements by 360 degrees. For example, the angle -90 degrees and the angle 270 degrees are coterminal. The angle 10 degrees and the angle 370 degrees are also coterminal. Any angles will be coterminal if the difference in their degree measurements is either 360 or some whole number multiple of 360. A unit circle is a circle with radius 1 placed on the xy coordinate plane so that its origin is at 0. The unit circle can be used to derive a new kind of angle measurement. Instead of using degrees, we use what's called radians. Now, a radian is defined as the length of the intercepted arc when an angle is placed on the unit circle. You may sometimes need to convert between radians and degrees. In this case, it's helpful to know that 180 degrees is equal to pi radians, and 360 degrees is equal to 2 pi radians. Likewise, 90 degrees is equal to pi over 2 radians. You can use these conversions in order to figure out any radian value in degrees and any degree value in radians. In order to find the values of trigonometric functions for certain angles, like we'll be doing later in this lecture, it's really useful to know the reference angle for any given angle. This is the smallest angle that is made with the x-axis and the terminal side of an angle when the angle is placed on a coordinate plane. Now that sounds complicated, so let's go quadrant by quadrant. In quadrant 1, the reference angle is just the angle. So if we have 60 degrees, the reference angle is just 60 degrees. In the second quadrant, the reference angle is 180 minus the angle. So if we have 120 degrees, the reference angle is 60 degrees. In quadrant 3, the reference angle is the angle minus 180. So, for example, if we have 190 degrees, the reference angle is 10 degrees. And for quadrant 4, the reference angle is 360 degrees minus the angle. So if we have 350 degrees, the reference angle is again 10 degrees. Reference angles can also be found in radians, and if you find your reference angle in degrees, again, you can convert it to radians. Now we're going to move in to actually finding trigonometric functions. The first two that we're going to learn are sine and cosine. You can find these by putting an angle on the unit circle. The angle is going to intersect the unit circle in one spot. Now, we're talking about the intersection of the terminal side with the circle, not the intersection of the initial side with the circle, because of course that's always going to be on the x-axis. So we take the terminal side and we find the point x, y, where it intersects the unit circle, and then we just look at that point. The y-coordinate of that point is the sine of the angle, and the x-coordinate of that point is the cosine of the angle. Those are only 2 of the 6 trigonometric functions, but you can use these 2 to find the other 4. Tangent of theta is going to be equal to sine of theta divided by the cosine of theta. Secant of theta is equal to 1 divided by the cosine of theta. Cosecant of theta is equal to 1 divided by the sine of theta. And cotangent of theta is equal to the cosine of theta divided by the sine of theta. Displayed on screen right now is a table of special angles that you'll need to memorize. For theta equals 0 radians, or 0 degrees, same thing, sine is equal to 0 and cosine is equal to 1. For theta is equal to pi over 6, or 30 degrees, sine is 1/2, and cosine is the square root of 3 divided by 2. For pi over 4, or 45 degrees, both sine and cosine are the square root of 2 divided by 2. For pi over 3, or 60 degrees, sine of theta is equal to rad 3 over 2, and cosine of theta is equal to 1 over 2. And lastly, for pi over 2, or 90 degrees, sine of theta is equal to 1, and cosine of theta is equal to 0. Any angles that have these special angles as their reference angles, you can also use this chart to find their sine and cosine. When we have the 3 sides of a triangle and we have an angle theta, we can find the value of the sine and cosine of theta. For sine, you take the side of the triangle that is opposite of the angle and you divide it by the hypotenuse. For the cosine, you take the side adjacent to theta that is not the hypotenuse and divide it by the hypotenuse. Now, for all the other trig functions, you can either find cosine and sine and then use the definitions that were provided earlier to find, say, tangent or secant, or they'll have their own definitions within a triangle. Tangent is opposite over adjacent. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent is adjacent over opposite. Next, we're going to talk about some basic trigonometric identities. The first two are called the tangent and cotangent identities, and these are just the definition of tangent and cotangent. So tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. Those are really simple. They're the exact same as the definitions. Next is a little bit more complicated. It's called the reciprocal identities. So, for example, sine equals 1 over cosecant, and cosecant equals 1 over sine. They're reciprocals of each other. Same goes for cosine and secant. Cosine equals 1 over secant, and secant equals 1 over cosine. And lastly, the same thing goes for tangent and cotangent. Tangent equals 1 over cotangent, and cotangent equals 1 over tangent. The next set of identities that you need to know is a little bit more complicated. They're called the Pythagorean identities. The first one is pretty simple. Sine squared plus cosine squared equals 1, no matter what the angle is. For example, let's take the angle pi over 2, or 90 degrees. We know that sine equals 1 and cosine equals 0. 1 squared plus 0 squared equals 1. What about, say, 30 degrees, or pi over 6? Well, we know that sine is equal to 1/2, and cosine is equal to rad 3 over 2 for pi over 6. So we square both of them. 1/2 squared is 1/4, and rad 3 over 2 squared is 3 over 4. Add them together, 3/4 plus 1/4 equals 1. It's true no matter what angle you pick. The same goes for the other two Pythagorean identities. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. Both of these also hold true for any angle that you pick. The next thing we have to learn about is the law of sines. You use the law of sines when you already know 2 angles in a triangle as well as one of the sides. So you can use those 2 angles to find the third angle, obviously, because you know, right, you know that the sum is going to be 180. So if you already know that you have a 50 and a 30, then you know that the last one's going to be 100. So you find all 3 of the angles, and then you can use the law of sines to be able to figure out any of the other side lengths, as long as you know at least one of them. And this is because side length A divided by the sine of the angle opposite to A, which is called capital A, will be equal to side B over sine of the angle across from it is equal to side C divided by the sine of the angle across from it. So you know what sine A, sine B, and sine C are. And then you can use those to find B and C if you already know A. The next formula is the law of cosines. You use the law of cosines when you know two of the sides and you also know the angle between that side. And then you can use this to find any of the other angles and sides in the triangle. So the law of cosines is that a squared, or any side squared, is equal to the sum of the squares of the other two sides minus 2 times the side length of the other two sides times cosine of the original side. So a squared equals b squared plus c squared minus 2 times b times c times cosine of the angle opposite of a. And that sounds really complicated, but once you just get to plugging numbers in, it's really not. The next thing you need to know how to do is how to find the arc length of an intercepted arc. So if you have a central angle of a circle, you need to be able to find the length of the arc that it intercepts. Well, in order to do this, you're going to need to find the angle in radians. And then you simply multiply the angle times the radius. So, for example, say you have pi over 3, a 60-degree angle, and you want to find the intercepted arc, and the radius is 4. Well, the number of radians, again, is pi over 3. You just multiply that by the radius, so you get 4 pi divided by 3 is the length of that arc. Next is the area of a circular sector. Now, a circular sector is a part of the circle, right? It is like a pizza slice out of this circle. It is something at the center of the circle, and it extends out, basically everything inside of an angle, right? The area within the angle. How do you find this? 1/2 r squared times theta. Remember, theta is going to be in radians. So you just plug that into that formula, and that's your area. Obviously, for any word problem involving trig, they're going to almost always give you some angles. Now, sometimes I'll just say angle ABC is equal to 60 degrees or pi over 3 radians. But sometimes I'll give you an angle in the form of an angle of elevation or an angle of depression. Now, an angle of elevation is the angle between a line of sight and the ground. And an angle of depression is the angle between a straight line of sight and a downward sloping thing. So say you're on top of a mountain and the mountain slopes down. The angle between a straightforward gaze that you have and the slope of the mountain is an angle of depression. But if you're standing at the bottom of the mountain and looking up at the top, you're looking up with an angle of elevation. You all know the area of a triangle is the base times the height. But sometimes you won't be given the base or the height. Lots of times you'll be given two sides and the angle between them. And you'll have to figure out the area just from that. Well, the formula is 1/2 times the product of the two sides times the sine of the angle between the two sides. And that is the alternate triangle area formula in case you can't use base times height. Knowing what we know, we're going to try to work through a couple of challenging trigonometry problems. Both of these are taken from prestigious math competitions. So let's start with the first problem, which is from the AIME. The question reads as follows. In triangle ABC, tangent of the angle CAB is equal to 22 divided by 7, and the altitude from A divides BC into segments of length 3 and 17. What is the area of triangle ABC? In order to do this problem, you're going to need to know the tangent summation formula, meaning that tangent of A plus B is equal to tangent of A plus tangent of B divided by 1 minus the product of tangent of A of tangent of B. So if you know that, you can solve this problem. So go ahead and pause here and try to solve. I'm assuming you've already paused, so let's get into the problem. Draw the altitude from A down. They're perpendicular, two right triangles, one on the left, which has 3 on the bottom, and one on the right, which has 17 on the bottom. So, we're going to look at the two angles that form at the top. The angle on the side with 17. Tangent of that angle, we're going to call that angle A, tangent of A equals 17 over h, which is the height of the altitude. And then we'll do the same on the other side. Tangent of B is equal to 3 divided by h. Then we simply plug these into the tangent summation formula. And then with a little bit of algebra, we can solve for h. Knowing h, we just use base times height because we know the base equals 20, and we can use that to find our answer. Problem 2 is also from the AIME, and it reads, given that log base 10 of sine x plus log base 10 of cosine x equals -1, and log base 10 of sine x plus cosine x equals 1/2 log base 10 of n minus 1. Find n. Now the first thing that we can do is use what we learned in session 8 to manipulate these logarithmic expressions and get rid of the logs. If you don't remember how to do this, go back and make sure you understand session 8 entirely. But we can basically get from the first one that sine x times cosine x equals 1/10. And from the second one that sine x plus cosine x equals the square root of n divided by 10. Now, let's take that second one and let's square it. So we get that sine x plus cosine x all squared is equal to sine squared x plus cosine squared x plus 2 times sine x cosine x is equal to n divided by 10. Remember, sine squared plus cosine squared equals 1. So we actually have 1 plus 2 times sine x times cosine x equals n over 10. Now remember, from the first expression we know that sine x times cosine x is equal to 1/10. So what we have is 1 plus 2 times 1/10 equals n over 10. So now we have 1 plus 1/5 on the left, which is 6/5, equals n over 10. We multiply both sides by 10, and we get that n equals 12.
That's all for today, everyone. Remember to like and subscribe.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!